This morning's session with Sarah, and now has GENI portal accounts and slices set up. And I'll just recap a little bit of what we learned the first time. What am I doing wrong here? Why is this?
Do you want it full size? Do you want full screen it?
Yeah, here we go. And got it. Okay, so hopefully everybody has been through the portal screen here and realized that that's integrated with a lot of in-common accounts, so chances are you were able to log in with an existing account through an academic institution or similar. And then after that you will have brought up a slice with a name from your sheet and been able to run the FLAC client directly within the portal. And this morning we brought up a very simple network topology with just two nodes and a link between them. And this will look familiar if you were here this morning. Hopefully yours looked green as well. And then right before lunch, the last step would have been to clean up those resources, again by using FLAC with the delete button shown there. So that's roughly where we should be up to. And now for the current session, we're going to some extent repeat a similar procedure, but this time we're going to pull back the curtains a little bit and look at what the details of the operations going on behind the scenes were. And hopefully you'll remember that there were 5 key phrases you learned about last time, such as project, slice, and so on. And now we're going to be adding 2 additional concepts that were not revealed previously, which are the mechanisms by which the resources are represented and commands are transferred. And so I'll be detailing these for a few minutes in the slides before we start the hands-on session. So the all the GENI resources are described in terms of what we call resource specifications, or aspects for short. The aspects are so widespread throughout GENI that the abbreviation is extremely common. And aspects are simply XML documents that describe networked resources, chiefly nodes and links. So at the bottom of this slide, at least if you're close enough to the screen, you'll be able to see a trivial example of an aspect with only a single machine in it. And about half of this file is boilerplate, and then if you can see this highlighted section is an XML element describing a single node. So at this point, none of the detail. Oops! I shouldn't have done that. Yikes! Let me get back to here. Okay, so none of the details are important, and it's probably not worth learning any of the details of the XML except on demand if you find you really need a feature. But it is useful to know that this is how the topology that you created this morning was actually communicated behind the scenes. There's nothing magic that the client did. If you'd had enough patience, you could have constructed the XML by hand. Not loud enough? It's not on. Sorry, I'll just try and shout for a few more minutes. So the 2 parties that are communicating the XML are the tool or the client on one hand, of which FLAC was the example this morning, and then the aggregate manager is the party responsible for allocating and provisioning and providing all of the resources. So there's actually three dialects of ASPEC that they use during the lifetime of a slice. So at the very beginning, before you even start designing your experiment, once you bring up FLAC, the very first type of ASPEC comes into play immediately, and that's because the aggregate manager already knows what resources it has available, and it constructs an ASPEC describing the available resources to the client. And that type of ASPEC is called an advertisement. And simply a list of the physical and virtual resources that particular manager can provide. And once that is done, the second step, which corresponds to the part where you would have been drawing out your topology on the canvas in FLAC, is summarized in what's called the request ASPEC. So FLAC is the client is responsible for generating this one, and it simply it's made up of only the nodes and links that you're actually about to bring up, and so that forms the request. And then the final variant is if the request is successful, then the aggregate manager constructs one last more detailed request known as the manifest, describing what was actually allocated to your slice. And generally this will correspond very closely to the request, but it'll be a little bit more detailed. So for instance, if you had a public IP address for the control node, that never would have gone in the request, because you don't know which machine. In general, it's more flexible to not care exactly which machine you're going to get as you ask for your topology to be set up. But once the aggregate manager has allocated those resources for you, it's important for you to know how to get to what you got. So that's the type of information that appears in the manifest. Client tool and the aggregate manager. So the list resources is the name of the API call that's used internally to fetch the advertisement in the first place. So the top pair of lines correspond to the client making the request to discover what's available, and an advertisement ASPEC is the result. Later on, once the client knows more or less what it wants, it constructs a request ASPEC and invokes create sliver, and there's which is the name of the call to actually realize the request. There's a slight error in this slide because a manifest isn't actually returned at testing. It's alright, I'll keep starting. That's better. Okay. Now I'm probably gotten so used to talking loud that I'm going to deafen you all.
Second one?
Yeah, I think so. Let's turn around a bit. Okay, and well, it worked temporarily. What have I done wrong now?
It's still.
Oh, still going? It just okay. And great, thank you. And then later on, after the sliver has been created, the client tool can then request a manifest giving it the details of the allocation. So we're going to be following through those steps manually ourselves in this session, whereas last time FLAC had been doing all of that for us behind the scenes. So let's step it a little bit and catch up on some time. These slides will be available on the website, but I think to speed things up, I'll skip through them for now. So what we're going to be doing is bringing up a similar experiment with the same kind of topology as last time, but instead of using FLAC the entire time, we're going to switch to a command line tool called Omni, which can carry out exactly the same role in the client and aggregate manager communication that FLAC did, but does things a slightly different way, and in some cases allows for more control. So we're going to start off by using FLAC again to edit the topology a little bit, and then we'll see how to save the XML aspect and use Omni to operate with it. So the four AM calls that we're going to be using are list resources, which again is the call that FLAC had originally used to retrieve the advertisement, and then create sliver. Once the request aspect has been constructed, that's the way it's submitted to the aggregate manager. Sliver status is then used to poll. You might remember that it took a few minutes where FLAC had shown you a yellow background and probably a spinning icon. What it was doing then was periodically polling with a sliver status call until the aggregate manager finally reported that it was ready. And then last of all, delete sliver. It was the last step we used to clean up at the end, to deallocate the resources that we'd used. So here's a little preview of what Omni running in a terminal is going to look like. Entirely command line driven, unlike FLAC, and it's suited to automation and scripting. So especially if you want to run an experiment a number of times with different parameters, that kind of thing might be one motivation for choosing Omni instead of FLAC. And let's see, I'll skip over these for now because we're going to go into them in more detail later. So at this point, I'd like to switch over to showing you how to configure Omni by following along the instructions on the worksheet. Does everybody have a worksheet for part 2? It should look like this one. If there weren't enough to go around, then hopefully you're...
It should say, what should it say at the top?
Understanding the GENI AM API through a simple experiment, and it looks like this.
So if you don't have that, raise your hand.
And if there are not enough, if even once all the handouts are gone, you can get to it by there's a bookmark inside the VM. So if you open up the VM and look at the bookmarks to the right of the portal bookmark, the same instructions are available online. Okay, so step 1 of those instructions should be on the following page. It'll say Part 1, Step 1, Establish Management Environment. And you'll see that there's the same 3-part procedure that we used this morning. The design and set up, followed by execute, and finally finished. And that rough roadmap is... will apply to essentially every GENI experiment. That's regardless of client or AM or anything. That those three steps still apply. So for the second page, most of you should have completed this already this morning. The create a GENI account and project lead adds you to a project should already have been done. If you don't have an account or are not yet in a project, then please ask for help now, because that's an essential prerequisite. And for everybody else, I'll assume you're up to step 3 on the established management environment page, the configure Omni. That's what I'm going to be walking through here. So let me just.
As a reminder for anybody using the VM, the password is up there on the easel.
And so please visit the portal page now and the Use GENI button again. And once you're there, please bring up the Profile tab from the set of tabs in the upper right-hand corner. And now we want to come down to this part of the page. If you see the heading Configure Omni, there's a couple of options, and we want to choose option 1, Automatic Omni Configuration. Now, under that, your VM should have Omni installed already, so step 1 should have been completed for you, and you can go ahead to number 2, download your customized configuration data. So please do that now, and you're likely to see the same screen that I have, saying that no certificate has been generated. If you've used Omni before, then just stand by for a moment. Otherwise, you'll get to this page, and please choose Generate Combined Certificate and Key File. And there's no need to download this now because it's going to be in the Omni bundle. Is that right? No need to download this now because it's going to be in the bundle, right? Okay, very good. So once you've generated the certificate, you can close that. It is not necessary to download yet. And if we reload the page, the warning that there was no certificate generated should have gone away now. And then you can carry on to step 6 from the instructions. Choose GEC17 from the project here, and then step 7 is this button here, Download Omni Bundle. And the browser should pop up with a prompt of where you want to save it, and the default location is going to be the place where it will automatically be searched for next. So please choose Save File, and the default Downloads directory is the right place. So it's easiest if you don't change it. Next thing you want to do is open a terminal window. You can get to it from this shortcut here on the bar on the left. And now you want to type omni-configure. So the spelling of that, sorry, omni-configure.py. So that's in step 8 in the instructions if you need to make sure you spell it right. And at this point, the file that you saved from the browser, the omni-bundle.zip, has your private key in it and the project you requested and your account name and so on. And the Omni-configure script is interpreting some of that and saving it under a .gcf directory in your home directory, which is where later steps are going to look for it. And now for step 4, if you were here this morning, you can skip over step 4. This is just generating and saving the SSH key pair. So I think this will not be necessary for most of you, but if you weren't here this morning, please do follow through through step 4. That's important because that's necessary for being able to log into the nodes later on. So if you haven't done that and have any difficulty, please ask with step 4. But for most of you, it will not be necessary if you were able to log into the nodes this morning. The same procedure will work. And now we go on to the Obtain Resources page. I think this is the 5th page in the instruction handout. And step 4, you'll see, is create a slice. And normally, most GENI experiments will start with this step, but since we've already created one this morning and it won't have expired yet with the default lifetime, we're going to save a little bit of time and reuse the same slice name that we already registered in the first morning session. So please step ahead to 4.1, the import a simple experiment in the on the 5th page of the handout. So you might remember that we manually constructed the topology last time by dragging nodes onto the canvas. We're going to take a slight shortcut this time and bring up FLAC again, and let me go back to the right place. You'll need to follow along to your. Oh, I went too far back. Please launch FLAC again on the same slice that you should have had from this morning, but instead of constructing the slice manually, you'll choose the import menu, and I'll show you that on the screen once my one comes up. It's going to be here. It's not ready on my machine yet. Perhaps if you're ahead of me, you'll be able to select it. Unfortunately, that spinning this icon here on the Emulab, it's the by far the biggest aggregate manager with 600 or so nodes in its advertisement. That's why it's taking much longer for that one than the others. But when it lets me, it'll enable this, and I'll. Okay, there we go. So now please, from the import menu, choose import from the web. And the URL you want to enter, it's on your worksheet as well as the instructions. And hopefully it's short enough that it won't take a long time to enter. protogeni.net/GEC17 TUT2.rspec. So you can copy along from what I typed, or it's also on the instructions in the worksheet. And then FLAC will bring up this message telling you that the RSpec does not include which aggregate manager you want the resources from. So please look at your worksheet, and it will tell you which aggregate manager to choose. I think it's the same AM as the one you used in the morning set. Oh, okay. If you got the worksheets together, it'll be the same manager that you used this morning, but it should be on the Part 2 worksheet regardless. So if I look at my own copy, I get GPO. Here we go, that's the one I'll use, and then please choose accept, and it should have imported an RSpec which won't look very unfamiliar. Now to see that FLAC can edit RSpecs as well as simply construct them, we're now going to make a few changes to request some software to be installed onto the nodes for us. So please turn over the page to step 4.2, and the worksheet will tell you exactly what we're going to install. iPerf is the important one. Please then on each of the two nodes, the server and the client, click on this I button, and then add installed service. And you'll want to copy the file names from the worksheet, because there's 3 or 4 strings to type on this step. So I'm going to go through it here, but you'll probably be better off ignoring me for a moment and following the worksheet, so that you don't miss an important character here or there. Okay, so all the magic words should be written down, and then please click the apply button once that's done. And it's important to do this on both the server and the client nodes. Same configuration on both of them. So one install and one execute service on each of the client and server nodes, with the little bit of text to type in from the worksheet. Okay, and then once that's done, we're not actually going to submit this from FLAC. This was chiefly as an example of how you can use FLAC as a graphical aspect editor. So for the next step, we're now up to 4.3 in the instructions, and the way to view the gory details of your work is to go to the View menu here and choose Preview Request Documents, and that will show you the entire aspect. And the aspects that FLAC generates are quite verbose. They contain a number of elements which are not strictly necessary, but allow FLAC to have nice features like history support and undo and redo, and remember the graphical layout of your canvas and things. So things that are not strictly necessary, but help to make FLAC a little bit friendlier. So don't get put off by this verbosity. If you really wanted to generate this XML file yourself, you could have done the same thing much shorter if necessary. And so look at that as much as you'd like, and when you're satisfied, we're going to save it to a file that we'll then import into Omni in a moment. So we'll put it in the downloads folder here, and let's give it a name. Pick any name you like that you don't mind typing in twice. Instagenia.aspect will do. And that should be all we need from FLAC. So if you're following along, you're now up to step 5 on the instructions on the worksheet, the instantiate the new experiment using Omni. So now please head back to the terminal, and the way to use Omni to instantiate a sliver, we're going to type omni.py, then -a and the nickname of the aggregate manager you're using, and this will be written down on your worksheet, so don't copy me, copy your worksheet instead, please. It will need to match the one that FLAC asked you. If you remember when you imported the aspect a few minutes ago, FLAC said there were resources with no aggregate manager attached, so you need to use the nickname that corresponds to the same aggregate manager that you chose in FLAC then. If you type a different nickname by mistake, like by copying my one, then this won't work. So please make sure that you're using the right aggregate manager nickname. If you're following everything from the worksheet, it should match up, but otherwise ask if you need help. And then after the -a option comes the command, which in this case is create sliver, the send along the request aspect and have the nodes brought up. And then there are 2 more parameters. The next one is the slice name, which again you're going to have to get off your worksheet. It needs to be the slice name that you registered on the portal. So this needs to match whatever it was that you typed into the portal this morning. And then the last parameter is the RSpec file. So whatever you had typed into export from FLAC a few minutes ago. In my case, it was instageni.rspec. So if that all looks good, then please give that a try. And I forgot to give it the full path name. Please don't make the same mistake I did. It's going to be in the downloads directory, and I forgot to say that. And this will take a minute or two, at least if once you get the correct file name, it might take a little bit longer. And so again, to recap, this is now Omni is now sending the RSpec file, which was originally created in FLAC, across to the aggregate manager. In my case, it's the InstaGeni rack at the GENI project office, but there are a number of other racks on different worksheets. And that request is now finished for me, and hopefully you'll get the same thing. If your result summary says got reserved resources, then everything is good. You can continue on. If you get up to this step and get a different result, please ask for help. And there's a few things which might have gone wrong at this point, such as mismatches between creating the RSpec for one aggregate manager and submitting it to a different one.
So I'd just like to check really quick. So how many people are at this point or like waiting for this script to configure? Please, to continue. Please raise your hand if you're at this point. Okay. So like a third of people. So I think maybe we probably should wait. Why don't we wander for a couple of minutes and make sure that we get people to this before we move on? Yeah, of course.
Sure, I'm happy to help.
Yeah, so this you can find on the worksheet, which is, yeah, there should be a worksheet that has the command. Yeah, maybe you guys didn't get a copy of the worksheet. So, okay, let me grab you one. I need another worksheet. Got it? Okay, great. Yep. So that's the command. Well, so that's the short line.
And what is the name? First of all, it seems it's my name as a manager of a slice.
No, this is the name of the aggregate that your slice is created on. So in this case, yours is created on the InstaGeni Kentucky.
Oh.
Do you want me to
so that's what
hand getting up to the Omni create for the request?
Yeah, please. Oh, awesome. Yeah, okay. Let's see, this one should be, actually Gary, I actually don't have to answer this one. Gary answered it for you. He's actually finished this experiment.
Yeah, it is the same one. That's because, yes, because the first exercise puts on custom install and execute scripts, and the second one doesn't. Yeah, I suppose you probably could. I haven't tried it, but I can't remember anything very long.
Sure.
Yeah, I think, that's right.
Alright, is it going okay for you now? Okay. Okay, we are on, let's see.
How do you see?
see where it's that command to. So where are you at?
It shouldn't need unzipping it.
No, because
Omni-
I
the
downloaded
Omni-
the Omni, no? The Omni is...
The Omni
The Omni
configure
box.
should unzip it by itself.
Oh, really?
Okay.
See-
And so you selected an aggregate manager. Correct. And then,
yeah, don't just leave it zipped up.
right, so what is it? Well, that's where we're going to be working. Is this is having you set up some different automatic results. So click on the little server, yep.
All is one.
And then it's got some information here for you to enter in.
So Omni configure is already installed.
Find the property archive URL. You want to add and install. Yes. And then this is the archive URL. And I'll come back and forth. Yeah, mostly. There's still a few people who. So we're going to talk about this one or next step.
So we're running a little bit short of time, so I'll continue on. If you are still following on, please don't hesitate to ask for help, or even at another session. There's the experimenter help desk at the other end of the corridor. There's lots of people from the GPO and elsewhere who will help. Are happy to help walk through this and all of the other tutorial material. So I'll continue on, but don't feel that there's any reason to stop if you're not at the same point. So now, with a bit of luck, I've left my creation request going for long enough that the sliver should be fully brought up by now. So that the step two, when there's a script that's distributed with Omni, the ready to login.py that's described in step 6.1. So this is a convenience. It's an example of how you can use Omni to give you some slightly higher level information. So it will actually send a sliver status request to the aggregate manager and parse it, and also request a manifest and parse out the SSH information it gets back from the manifest. So it won't work if you try it too quickly after the create sliver. It will tell you that the resources are not ready yet, but I've left mine going for a few minutes, so it will likely work the first time for me. You want to say ready to login.py -- no -keys. And that, again, step 6.1 of the worksheet has this written down. Then -a and the same aggregate manager nickname you used. So for me, that's IG-GPO, but for you, it's probably likely to be different. And then slice name, which for me is iGenio2, and again is going to be different for you. That will take about 5 seconds, and then if the sliver is ready, it will give you some output like this, giving you example commands of how to log in to the client and the server nodes. So once you reach this point, please copy and paste these two instructions. Copy and paste the client instruction. So I'm going to copy that first one down, and in your case, of course, copy what ready to login tells you. And when you log into the client machine, you'll need to supply the passphrase you used on your SSH private key, and then you should be logged in very much like this morning's session. And we're now up to step 6.2, and we can investigate what the experiment is doing on that machine. So those, if you remember the install and execute scripts that we had typed into FLAC, giving it the tarball and the command to run, that has set up a web server on the server node, and a wget on the client, a number of wgets on the client, and also an iperf running in server mode on the server, and a script running iperf a bunch of times with different parameters on the client. So once you logged into the client machine, you can see if things are all working well. I think there's a delay in the script, so if you try it immediately, there won't be results there, but you'll only have to wait a minute. Silly me, I changed to the wrong directory. iperf logs, that's what we want. And under temp iperf logs, a whole bunch of files should be appearing if everything went well. So the details of the experiment are probably not interesting to you. They're just running iperf with a different number of simultaneous connections, but this is intended as an example of how you can automate experiments in GENI pretty easily. So you can imagine if you wrote if you wanted different aspects generated with slightly different topologies each time, you can see that XML output is not difficult for a script to generate maybe, and if you have your own software that you'd like to run under different conditions, then using install and execute scripts is a pretty convenient way of getting there, compared to maybe having to drag out different topologies in FLAC would get pretty tiring if you have to do it maybe dozens of times. So I'll look at one of these files just to make sure that things have all run properly, but the details of what are in the files are not exactly fascinating. So there we go, a whole bunch of iperf results. So I'm going to clean up now so that we have time to move on to a couple of other things in this session. But feel free to inspect the experiment setup as much as you'd like, because some of it might be interesting if you want to use it as a basis for your own slices later on. But I'm going to skip right ahead to step 7, exit out of the VM, and now the part 3, the cleaning up, is to run Omni -A with the same nickname again, and then the command is delete sliver.
So while Gary's running this, I'll mention, so when you create slivers reserving resources in GENI, you get they get reserved to you for some period of time. The default is a couple of hours, but you can ask for longer, and you can renew them once you have them. So what will happen to the slivers that you guys have created today is that they will get deleted sometime this evening if you just leave them alone and let them expire. But the command to clean this stuff up will help make sure that we have plenty of VMs for the third part of the tutorial this afternoon.
So at this point I'll mention there's another exercise which I'm not going to walk through to save time, but there's a worksheet and instructions for it. It's called Part 2, Exercise 2, and I don't have one to hold up, but it's got it shows how to use Omni to bring up the same kind of ping plus exercise that you did this morning. So feel free to work through that at your own pace. If you're running a bit ahead, then feel free to start it now. Otherwise, you're welcome to run it in your own time, or ask the experimenter help desk if you'd like assistance walking through at any other time during the GEC.
Okay, so the question that I was just asked a question that I'd like to answer for everybody because it's a good question. So the question was, let's say that you're working on like a kernel module or something, and you manage to like wedge one of your machines. So what do you do about this? There's a couple answers to this. So let's see. Am I in full screen mode? Oh dear. There should be. Oh dear, I'm having trouble finding it, and I think it's because the resolution of this screen is so low. Oh, I know why. It's because we haven't actually created this this slice. If I'd actually successfully created this slice, there would be a button at the bottom of this middle column that let me reboot the nodes in my slice. So that's one way to fix it. Another way to fix it is that I mentioned earlier that there are that InstaGenie and ExoGenie have kind of different tools. So we do have serial console access for all of these things, but it's not exported through the Genie interface. So if you're doing some kind of heavy kernel work that requires you to frequently have serial console access so that you can debug kernel problems or whatever, you should send mail to the InstaGenie users list, which I guess it probably isn't listed anywhere on our handouts, unfortunately. There's an instagenie-users@googlegroups.com list that you can join, and I'm sorry, it's protogenie-users. We don't have an instagenie users list. And we can set you up with serial console access. If it's just like you mess a machine up once and need to reboot it, I would just recommend doing it through FLAC. I hope that answered your question. Okay, so when you use FLAC to load a slice that has already been created, in fact, if you've successfully created this slice, in the middle column, like where the submit button is now, once the slice has been created, there'll be a button there to restart all of the nodes in your slice. So you can actually reboot them yourself. And then if you need serial console access, it's a little bit more complicated process, and you can email us and we can get you serial console access. So let's see, Gary, do you have any created slices? Oh, actually, let's see, maybe.
Should have deleted it. It might still be there by mistake, but. Yeah, that IGE slice will be the only one, but I should have.
Let's see.
I should have deleted it.
I'm going to see if there's any slivers left in this slice, and if there are, I'll try to show you the button that I was talking about. I'm trying to think if I think I deleted the ones that I made this morning too. Yeah, it looks like not. I'll go ahead and try to set it up so that I can show you the button in a minute here, but it'll take a minute for my slice to get created. So. Any other questions I can answer while we've still got a few minutes? All right, well, we'll hang around here to answer questions one-on-one if people have them. And, oh, here, this button appeared. There are these three buttons down here that would let me stop and start and restart the nodes in my slice. That you can now see above the submit button. Also, I mentioned earlier that these things expire after a while, and if you want to keep them longer, you have to renew them. This is also where you can renew them. There's this button here that lets you extend stuff for. Sorry. That lets you extend stuff for a few more days, and if you need a really long running one that's going to run for weeks or months, we can actually give you a special credential that lets you extend your reservation for longer.
So what happens when reservations expire?
Then all the virtual machines are torn down, or physical machines get rebooted and put into another operating system.
Does the thing pop up and say, "Would you like to continue," or does it just all collapse?
You will get email if your slice is going to last for more than a day. You'll get email 24 hours before warning you, and giving you the opportunity to renew it. But then when the expiration time comes, it all gets pulled out.
Flack will tell you nothing; it will just disappear.
That's correct. You probably won't have Flack open in a couple days when it expires. But yeah. Well, we'll be around to answer one-on-one questions, and for those of you who'll be back for the third part of the tutorial, again, if you didn't get that last slice created, ask one of us so that we can try to make sure that everybody starts the session with their slice created. And thank you.